Okay, chapter 3.1, remainder theorem and factor theorem. Okay, let's try to divide a number. Look at this. Okay, I want to divide. When we divide 9 by 2, then what do? We use a long division, so 9 divided by 2. Then we are looking for a number so that the product of 2, the divisor, is 9 or less, right? So 4, then 2 times 4 is 9. Then what do we do next? We do subtraction, right? We do subtraction. Let me use something like this in subtraction. So then that is 1, right? Then once we have this, we can say that this is the quotient, right? Quotient. And this is the remainder, right? So, okay, and then we call this 2 divisor. Okay, divisor. And this is the dividend. So when we get the quotient and remainder, we can write the answer like this. 4 and, actually it's 4 and 1 half, right? 4 and 1 half. Or same as this one, 4 plus 1 half. Same thing, right? So whenever we have a division, we can actually divide like this. We call it a long division. But how about polynomial? Let's say here's a polynomial. I want to divide 6x cubed minus 8x squared plus 12. So I want to divide this polynomial by 4x. Okay, this is a really simple one because in this case, you can, because the denominator is a monomial, like a 4x monomial, right? So when you have a monomial like 3 halves plus, let's say 5 halves plus 1 half. Then how do you add this one? Since the denominator is the same, we can add the numerator, right? Add the numerator like this. So if you go backwards from here to here, you can separate each term in the numerator by the same denominator like this. So same as this, we can use this concept. We can separate each numerator, the terms in the numerator by the same denominator. Can you see it? So that we can easily reduce and simplify each term. Then this will be 4x squared minus 2x plus 3 over x. Oh, did I do something wrong? Oh, so we can write it like this, right? But if the divisor is not monomial, it is like a binomial, trinomial, and so on. So if the divisor is more than one term, then we can use long division, just like what we did, 9 divided by 2. Okay, then let's try this. 6x cubed minus 16x squared, and this fourth term polynomial is divided by 3x minus 2 binomial, so that we can write in a long division form. So when you write it, make sure each term is in descending order by the degrees. So the highest degree comes first. And also if there is a missing term, then put 0. So let's say 23x is missing, then put 0 on this slot, on this place. Okay, so this one is divided by 3x minus 2. Same thing, 3x minus 2. If you have to write in descending order. Okay, next, what we're gonna do is, just like in a division, we wanna find something. So so the product of the first term and this one should be equal to 6x cubed. Can you see it? So what you can do is, divide 6x cubed by the divisor, 3x. Because 3x times something should be equal to 6x cubed, right? So what is this something? This something will be 6x cubed divided by 3x. All right. Then this will be 2x squared, right? So this quotient will be 2x squared. So 2x squared times 3x is 6x cubed. Can you see 3x times 2x squared is 6x cubed? All right. So then once we found this term, then multiply negative 2 with 2x squared. So that will be minus 4x squared. Then write it next space. So make sure, when you write a term, each column must have the same degree. So make sure, the first column is for the degree 3. The second column is for the x squared terms. And then we do what? Minus, right? Minus. So subtract. So top minus bottom. So top minus bottom is, this is 0, so you don't have to write it. Negative 16 minus negative 4. Let me use minus sign. So negative 16 minus negative 4 is plus 4, isn't it? So negative 12x squared. All right. And then since the divisor has two terms, you can bring one term down. Or you can bring all the other terms down. Still okay, but we don't need others. We need two terms only because the divisor has two terms. And then we do the same thing. So 3x times something, I don't know what this something is, should be equal to negative 12x squared. So what should we multiply? Negative 4x, or negative 4x. And how did you get negative 4x? You can do it like this. So divide negative 12x squared by 3x, then negative 4x, right? So this negative 4x comes over here. Then negative 4 times 3 is negative 12x squared, right? So multiply negative 2 by negative 4x, then plus 8x. Next, what do we do? Subtract, subtracts. Top minus bottom. So 28 minus 8 is 17x, right? 17x. Okay. Sorry, 15x. Alright, then bring the next term down. Minus 5. Now do the same thing. So 3x times what? 3 times what becomes 15x? Isn't it? 5, right? 5. So plus 5. So that 15x. Then multiply negative 2 by 5. So negative 10. And then we do the subtraction. Then the first term is 0. Negative 5 plus 5, right? Plus 5 because we do the subtraction. So 5. So 5 is the remainder, isn't it? 5 is the remainder. Alright, so we can write it like this. So this is the remainder. Okay, and this is the quotient. So that the answer will be the quotient. Now write the quotient plus, then we need to write the remainder, right? Remainder. So 5 over, always make sure 5 over, 5 is the remainder, so remainder is out of the divisor, 3x minus 2. So you can write it like this. So that's the answer, when you divide a polynomial by a polynomial. Alright, so as you see the division, look at this. Okay, 9 divided by 2. So 9 divided by 2, we can write it like this. Okay, 9 is the quotient, right? 9 is the quotient. Sorry, dividend, nice dividend. So, okay, let's use this one. We have a polynomial. Okay, for the second example, we have the polynomial, right? Polynomial is divided by a divisor. Let's use a D as a divisor. A divisor is so that's, what did we get? Now we get the quotient, right? We get the quotient, Q of X, and then the remainder, so R of X. All right. So if you rewrite it, it can be like this. Polynomial is divided by divisor, so that we got the quotient and the remainder like this. So from this, multiply each side by D of X. Then we have a polynomial So the polynomial is equal to what? Okay, actually this is the remainder is once we have the remainder, then the remainder will be divided by what? Dx, right? Divisor. That's what we did, right? That's what we did. So I'm sorry, this has to be this one. So multiplying each side by the divisor is going to be q of x times d of x plus r of x over d of x times d of x. So that the remainder parts can be simplified. So we can cancel out d of x, so it has r of x. So here is another expression related to division. Okay. So when you divide a polynomial by another polynomial, then we can write it something like this. So the divisor is equal to, the polynomial is equal to the quotient times the divisor plus the remainder. Can you see it? It's just an example of the relationship between the division, polynomial division. Alright, then let's divide this polynomial by x minus 3. So when we write it, divide the dividend, write the highest exponent term first. So it will be x to the fourth power, right? X to the fourth power. So if we rewrite it, then this will be x to the fourth power, and then there's no cube function, so write the next one, which is negative 5x squared minus 8x plus 3 divided by x minus 3. So let's divide the numerator. So let's divide x to the fourth power plus, there is no x cube, right? No x cube. So put 0 and then negative 5x squared minus 8x plus 3. So make sure if there's a term missing, then put 0. Then I'm going to divide this by x minus 3. Alright. So now we need to find the first term. So x times what becomes x to the fourth power? X cubed, right? X cubed. So multiply the next term by x cubed, which is negative 3x cubed. And then write it next to x to the fourth power. Because each term, each column must have the same degree. Okay, same degree, like terms, must have the like terms. So we divide it, so top minus bottom is 0. 0 minus negative is positive, so plus x cubed. Okay, and then put in the next term down, because the divisor has two terms. X minus 3 two terms, so we need two terms. Alright, then plus, okay, x times what? Become 3x squared, 3x cubed. We need 3x squared, right? 3x squared. So that x times 3x squared is what? 3x cubed. Okay, then multiply negative 3 as well. That is negative 9x squared. And then we do the subtraction, right? Alright, then the first one is 0. The next one is negative 5 plus 9 is 4x squared. Then bring the next term down. Do the same thing. So x times what becomes 4x squared? So we need 4 and x. So there will be 4x squared. Then multiply the next one. So negative 12x. And then subtract. Top minus bottom. So negative 8 plus 12 is 4x. Okay, the last one. Bring the last one down. Look, the degree of the divisor is 1, so x minus 3. And then we're gonna divide 4x plus 3, same degree, right? Same degree. So this is the last step for the division, the last one. Alright, so plus 4 will make 4x. Then multiply negative 3 by 4, so negative 12, and then subtract. Then that's 0, and then plus, so plus 15. So this is the remainder, right? So we found the remainder. And this is the quotient. Right. So what's the answer? So the answer will be the quotient. X cubed plus 3x squared plus 4x plus 4, right? Quotient plus the remainder. The remainder is 15, so make sure the remainder should be divided by the divisor. Okay, so this is the answer. All right, so we call this long division. Okay, we call this long division. Okay, so this process is long division. But now next step is, next concept is synthetic division. Synthetic division is much easier, much faster, and then convenient. So let's learn the synthetic division. Okay, the synthetic division is this. Okay, we're gonna write only the coefficients. So let's use the same information, same example. Let's use the same example. So I'm gonna write the numerator, the coefficient of the numerator. So that is 1. And then, x cubed. X to the fourth power is 1, right? X to the fourth power. The coefficient is 1. And there is no x cubed. So if there's no x cubed, then put 0. Then x squared term has coefficient -5. And x term, the coefficient is -8. And constant is 3. So write only the constants and the coefficients. And then draw a symbol like an L symbol. And then give us space on the next line, because we're going to write something in the next line. And I'm going to divide this by x minus 3. Okay, x minus 3. Then, okay, the divisor is x minus 3, right? X minus 3. So if we make it 0, then x equals to what? 3, right? 3. So we will use 3. So we will divide this by 3. All right. So since the divide, okay, don't get confused. If the divisor is x minus 3, then make it 0 so that x equals 3. X becomes 3. So we divide by 3. Then next, what we do is, okay, first drop the first one down. So write it 1 below the line and then multiply. Okay, we're going to multiply these two. Multiply. And then write it in the next, the second line. So write the product. So it'll be 3 times 1 is 3. Okay. And then add the column. So 3 plus 3. 3 plus 3 is what? 0 plus 3 is 3, right? So bring it down. So add it. And then do the same thing. Multiply 3 and 3. Multiply 3 and 3. Then that goes where? That goes next line, 9. And then add these two numbers. Then there will be 4 and 4. Do the same thing. Multiply 4 by 3. So always multiply this number 3. Then 3 times 4 is 12. That goes to the next line. And then add it. Do the same thing. So 3 times 4 is 12. Then do the same thing. Add it. 15. Now for the long division, what we did is we subtracted, right? We subtracted. But synthetic division, we add. Okay, add. And then for the long division, we divided by x minus 3, right? We used x minus 3 as it is. But when we divide using the synthetic division, we divided this one by positive 3, right? Positive 3. So it's a little bit different. And then make sure to put a little square box like this, so that we know the last part is the remainder. Okay, so this is the remainder, 15. All right, so we have the same remainder, right? 15, and then we have 4 terms, 4 coefficients. Then these are the coefficient of, okay, the last one is the constant. This is the coefficient of x, variable x. This is the coefficient of x squared, and this is the coefficient of x cubed. All right. So the answer is, write down these 4 terms, x cubed, 4 terms, x cubed plus 3x squared plus 4x plus 4. Can you see it? So the last one is the constant, and as you go to the left, the degree of x increases by 1. And then plus, the 15 is the remainder, so write down 15, and then the remainder, the divisor, x minus 3. Right, so we have the same answer. Same answer using the quotient and the synthetic division, using the long division method and the synthetic division method. So we got the same answer. Okay, let's try more. Let's try more example. Alright, so we're gonna write the dividend, only the coefficient of the dividend. So we have a 2, and there is no x squared term, so put 0. And then x term, negative 8, constant 7. And then put a L symbol. And then we are dividing by x plus 3, right? So make it 0, then x equals negative 3. So put negative 3 here. And then bring the first coefficient down, and then multiply, right? Multiply. Then negative 6, right? So put it here, and then add 2 terms, that is negative 6. Then multiply negative 6 by negative 3, that is 18, right? 18. And then add these 2, that will be 10. Multiply 10 by negative 3, that's negative 30. And then add it, that's negative 23. And then put little square like this. So the remainder, what's the remainder? This is the remainder, right? Remainder. And then there are 3 terms. So this is 10 is the constant, negative 6 is the coefficient of x, and 2 is the coefficient of x squared. So the answer is the 3 terms, 2x squared minus 6x plus 10. And there's a remainder, so minus 23 over the divisor. All right, so this is the answer. So, you can, since the remains negative 3, I put the negative sign outside. Still okay. All right, then let's try more examples. All right, so we're going to divide these 4 terms by x plus 4. So write the coefficient. So 1, x to the 4th power is 1, and there's no x cubed, so put 0. The coefficient of x squared term is negative 4, 7, and 15. L shape. So here it is x plus 4. If I make it 0, then what's x? Negative 4, right? Negative 4. So put negative 4 here. And then bring 1 down. Then multiply these 2 numbers and write it here. Negative 4, right? Negative 4. Then the sum is negative 4. Multiply, so that's 16. Then sum is 12. Right? And then multiply, that goes over here. So negative 48. And the sum is negative 41. The number is getting large, right? So 41 times 4 is positive 164. Then add it, then 169. So this is the remainder. Bingo. This is the remainder. And then, negative 41 is a constant. 12 is the coefficient of x, x squared, and x cubed. So finally, the answer is what? X cubed minus 4x squared plus 12x minus 41. And then the remainder is plus 169 over the divisor, x plus 4. So, that's 15, sorry. This is 15, right? So it's going to be a 79, right? 179. Okay. So using the synthetic division is much easier, much simpler than using long division. Okay, let's check this theorem, remainder theorem. So remainder theorem is this. If a polynomial p of x is divided by x minus c, so something like this. So p of x is divided by x minus c. Then the remainder is p of c. So what do you mean by p of c? P of c means replace x with the value c, right? C. Okay, so let's check. So if you divide this by 2, then what? Okay, do you remember? Okay, do you remember the long division? P of x is divided by x minus c. This is the x minus c is the divisor, right? Divisor. Then let's say there is a q of x, and then when you do this one, then there is a remainder, remainder. So actually, when we divide these two, then we can write it as what? Q of x plus remainder divided by x minus c, right? So that if we multiply x minus c both sides, now we're going to multiply x minus c, then this will be q of x times x minus c, right? And then r of x over x minus c times x minus c. So if we rewrite it, p of x equals q of x times x minus c, and we have the remainder only, right? So from here, when we divide by x minus c, right, x minus c, so if we plug in c for x, okay, I'm going to plug in c for x, then what happens? I don't know what this q of c is, but I'm pretty sure that x minus c becomes c minus c and becomes 0, right? R of c, right? So as you see this one, this is equal to, this part becomes 0. So q of c times 0 is 0. So what we have is only the remainder, right? Only the remainder. So that's what it means. So that the remainder, so what's the remainder? The remainder is p of c. Okay, this is the remainder. So p of c is the remainder. So if you divide polynomial by x minus c, then this c, replacing x with c becomes what? The remainder. Can you see it? Okay, so don't forget this formula. P of x, actually this one, p of x, right? P of x equals the quotient times the divisor, x minus c, plus the remainder. So whenever x is replaced by the same number c, then this part becomes 0. So we have only the remainder. Okay. Alright, let's see p of x is 2x cubed, blah blah, and then find p of c. Okay, for c values are given. So we want to use the synthetic division. Okay, as you see this one, the remainder theorem, if a polynomial p of x is divided by x minus c, then p of c is the remainder, right? P of c is the remainder. So divide p of x by x minus c. That's important. So in order to find p of c, we're going to divide p of x by x minus c. So let's divide it using synthetic division. Write down only the coefficients. So 2. So the coefficient of p of x is 2, 3, 2, and negative 2. There's no missing term, so there's no zeros. Then I'm going to divide this by x minus c, right? X minus c. And then what's the c value? Okay, if c equals, c value is given, so let's use negative 2. Okay, x minus c means, dividing x minus c means we are dividing it by what? C, right? C. So using the synthetic division, then we will use c, not minus c. Use c, right? C. Then for the c value is given, right? For c equals negative 2, so use negative 2. Then bring the first one down, multiply, then put it here, right? So negative 4, then add it, negative 1, multiply, positive 2, add it, 4, multiply, then negative 8, add it, so negative 10. So look at this. So when we divide the polynomial by x minus c, then P of C is the remainder, right? So the answer, what is P of negative 2? That's the remainder, right? That's the remainder, right? Remainder. Okay, let me write it. Just remainder. That's the remainder. What's the remainder? Negative 10. So P of negative 2 is equal to what? Negative 10. That's it. Simple, right? Simple. So since we are using the synthetic division, it's much easier to find the remainder. But you can just plug in, negative 2 here. Or if you are not using synthetic division, then P of C is equal to what? And actually, you replace x with negative 2. Replace x with negative 2. And this is going to take a little bit longer time. Right? Then negative 2 times negative 8 plus 3 times 3 times 4. And then minus 4 minus 2. So that is negative 16 plus 12 minus 4 minus 2. So that is negative 4 minus 4 minus 2. So negative 10, right? So we have the same answer anyway. But, this one takes, sometimes, plugging, x with the x value may take time. So synthetic division is sometimes, is much easier to find, when x equals something. All right, then for x equals 1/2. Let's find the remainder. All right, so write down only the coefficients, 2, 3, 2, negative 1, negative 2. This is divided by, okay, now C is 1/2, right? So use 1/2, then bring the first coefficient down, and then multiply these two. That will be 1. Add it, 4, then multiply, that is 2, right? 2, another 4, multiply, 2. Then add it, 0. Look at this. The remainder is 0. Right? So, when you plug in 1/2 for x, then the answer will be 0. The remainder. So actually when you do this, if you plug in, this really takes time because I want to get f of c. Or you can try it like this, P of c. So c is 1/2, right? If we plug in 1/2, then what? 2 times 1/2 cubed plus 3 times 1/2 squared plus 2 times 1/2 minus 2. This takes time. 1/8 plus 3 times 1/4 plus 1 minus 2. Then this is 1/4 plus 3/4. And then add this to is negative 1. Then if you keep going, 3/4 and then minus, this is 4/4. So finally 1 plus 3 minus 4/4. Then that is equal to 4 minus 4/4 is 0, right? 0. So we got 0. And this one takes time, right? So using synthetic division is much easier to find the value of P of x, P of c. All right. So this should be P of c, right? P of c, or you can write it as P of c equals P of negative 2, right? Negative 2. All right. So can you see it? So we want to find P of some input. Then what do? Use the synthetic division, and the result is only the remainder. Only the remainder. Or you can just plug in, replace all the x variables with the x value. But it takes time. All right, let's try. Okay, let's try to find P of 7. Okay, P of 7 means you have to plug in what? P of 7, that means we're going to replace x with 7, right? So 7 to the 5th power 10 to 10 times 7 to the 4th power plus 35 times 7 to the 3rd power. You know, this number is huge. It's a really big, right? Really big number. So if you keep doing this, it's too much work, right? But let's use synthetic division. So find F. So P of 7 means what? P of 7 means, okay, this means divide the polynomial by what? X minus 7, right? X minus 7. Same thing, right? Same thing. Then the answer will be the remainder. So P of 7 is the remainder, right? Remainder. All right, so that is better. So let's use a synthetic division. So the coefficients of the polynomial is 1, negative 10. Is there any missing term? Well, nothing, right? Nothing, but the constant term is missing, constant. So we put 0 in the constant column. So divide this by what? 7. The x value is 7, right? X value is 7. So x minus 7, so x is 7. All right. Then bring one down. And then multiply 7. Then add it. So negative 3. Then multiply negative 35. Now become 0. Oh, sorry, 21. Sorry. Minus 21. So that is 14. And then multiply by 7. Then $98. Then add it. So it's 48. Then multiply by 7. Then 360. Oh, wait a second. 336. And then add these two, then 360 and multiply by 7 is 0, 2, 25. So finally, the remainder is 25, 20, right? So that's the answer. So this is the remainder. So this is what? P of 7, right? P of 7. Therefore, P of 7 is equal to the remainder, 2,520. So, you know, when you solve this one, then the remainder will be 2,520. It's a long way, right? Long way. But so sometimes using the synthetic division, you know, the remainder theorem is much faster. Faster, you know, when you evaluate the polynomial. All right, the factor theorem. You know, this theorem is really simple because we already know. So let's say, you know, 8. Okay, let's say, all right, so the factor theorem. Okay, let's use a number. Let's say 6. Okay, now 6 is a product of what? 2 times 3, right? There's no remainder. 2 times 3. So we call this, each of this is called a factor, right? Factor. So this means when you divide 6 by 2, then that is 3, right? 3. And no remainder. So this one has no remainder. No remainder. Right? No remainder. So when you divide 6 by 2, then 3. So 2 times 3 is 6. Then the remainder is 0. There's no remainder. Right? So if something is a factor, then there's no remainder. If there's no remainder, that means it's factorable, right? Factorable. So P of x has a factor. So x minus c is a factor. So we can write it something like this. P of x equals the quotient. I don't know what the quotient is, but the quotient times x minus c. Factor, right? Factor. That means there's no remainder. So remainder is always 0. This is remainder, right? Remainder is 0. So we can write it as something like this, right? So since this is a factor, Since it's a factor, what happens if we plug in C? Plug in C for x. So replace the input variable x with the value C. Then what happens? C minus C is 0, right? C minus C is 0. C minus C, right? So that this part becomes 0, then this result is 0. Can you see it? All right, so factor theorem is really simple. If P of x is factorable, then let's say x minus C is a factor, then plug in x for C is equal to what? 0. So P of C is always 0. So a polynomial is 0, that means C is a 0 of the polynomial. That's what we call, right? That's what we call. Right, you know, you have a, okay, so if you rewrite it, then P of C is equal to 0. Okay, and then, you know, you have a polynomial. Let's say, you know, x squared plus 4x plus 2 is equal to, okay, let's say this is a function y. And then if you set the function equal to 0, if you set the function equal to 0, then, you know, those x values, in this x will be negative 2. Then this will be 0, right? This is 4. Then once you solve it, x is negative 2. Then what do we call this one? We call this 0, 0 of a function. 0 of the function y. That's what we call it. Right? So since this is equal to, you know, x plus 2 times x plus 2 is equal to 0. So by setting each factor, you know, these are the factors, right? Factors. This is a factor, this is a factor. So, you know, this y is a product of, you know, these two factors, right? This is a factor. So y, P of x has a factor. So P of x, you know, y has a factor x plus 2. Then what? P of negative 2 will become 0. Is it really true? Yeah, plug in a negative 2 here. Negative 2 plus 2 is 0, right? 0. So that makes sense, right? That makes sense. So very simple theorem. If P of x has a factor x minus C, then P of C is 0. And that C value is what? The 0 of the function. So once you plug in, you know, replace x with the value C, then the polynomial is 0. Okay, really simple. All right, use the synthetic division and the factor theorem to determine whether x plus 5 or x minus 2 is a factor of polynomial. Okay, if this is a factor of a polynomial, then what? The remainder has to be 0, right? So factor of polynomial means the remainder has to be 0. So let's find, so when we divide, okay, we can write it. So the remainder will be 0. Okay, when dividing P of x by x plus 5, right? Or P of x divided by x minus 2. So when we divide the polynomial by x plus 5 or x minus 2, then the remainder is 0. Then that is the factor, right? That's the factor. All right, so let's try. So first, let's divide it. Let's divide P of x by x plus 5. So use the synthetic division. So I'm going to write the coefficients of fourth power, third power, second power, first power, and the constant is 20. So I'm going to divide this by what? X plus 5, right? X plus 5. So I'm going to use minus 5. Okay, negative 5. So divide this polynomial by negative 5. So bring 1 down and then multiply. So add it, multiply, add it, multiply. So add, and then multiply, negative 20. Look at this. The remainder is 0. The remainder is now 0. Right, so by the factor theorem, x plus 5 is a factor. So x plus 5 is a factor of p of x. So actually p of x is what? X plus 5 times something. I don't know what this something is, but this something should be this guy, right? This guy. Right? So this is the q of x. So if you rewrite it, then p of x equals x plus 5 times, okay, this is x term, this constant, x term, x squared, x cubed. So you can write it x cubed minus 4x squared minus x plus 4. All right, so we can answer only this one. We just want to determine whether x plus 5 is a factor of this. So this is enough. But if you go further, then we can write the function as this. P of x as a product of x minus 2 and this one. All right, then let's try the next one. So let's divide p of x by x minus 2. And let's see whether the remainder is 0 or not. So I'm going to write down all the coefficients of polynomial. And then divide this by what? 2, right? 2. Not negative 2. It's got to be 2. So bring 1 down. Then multiply. Add. Multiply. Add. Then multiply. Add. Multiply. So 61. And then sum. The sum is negative 41. This is not 0. This is not 0. The remainder is not 0 since the remainder is not equal to 0. X minus 2 is not a factor. Not a factor of polynomial. Okay, can you see it? All right. All right, so let's summarize, and this is all equivalent. Okay, when pure polynomial is divided by x minus c, then the remainder. Okay, the remainder is equal to what? Plug in x for c, right? C. So replace x with the value c. Then the remainder is p of c. And then also the remainder is 0. So once the remainder is 0, then what is it? Then x minus c is a factor, right? So number 2. So if x minus c is a factor of p of x, then the remainder is of course 0. And then if the value x, if the value of x is c, then we call it what? Since the remainder 0 is a factor and the p of x becomes 0, p of x becomes 0, so we call it 0 of p of x. So 0 of a p of x. And also, so p of x is y value, right? Y value. So y is 0, then c is the x-intercept. Does it make sense? So let's say this is x-axis, y-axis. Just an example. So you have something like this. So let's say this is 1, this is 4. Let's say this is negative 3, something like this. Then this is, let's say this is a polynomial, okay, polynomial. So this is the graph of the polynomial. Then we can say something like this, x plus 3 times x minus 1 plus, sorry, not plus, x minus 4, right? So we can write the polynomial like this. So from here, we know that what are the x values? What's p of x? If x equals negative 3, 1, and 4, then makes the polynomial equal to 0, right? Polynomial equal to 0. So that is the x-intercept, isn't it? So when x is negative 3, then y is 0. x equals 1, then y is 0. Also when x equals 4, y is 0. So these are all what? X-intercept, right? X-intercept. So and then once the p of x is 0, then those x values are called what? 0 of the function, right? 0. We call this zeros of p of x. That's what we call, right? And since these are the factors, right? Since these are the factors, right? Factors, p of x is divisible by each factor, right? Divisible by each factor. So that the remainder is 0. There's no zeros, right? Because it's factorable, so there's no remainder. Okay, let's try. Now, let's find a reduced polynomial. So when we divide a polynomial by something, then let's write the polynomial in factor form. Okay, next example. Okay, let's verify x minus 3 is a factor of p of x. Then how do we verify it? Okay, we will divide p of x. Okay, divide p of x by x minus 3. Then the remainder should be 0. Right, the remainder should be 0. So which means p of 3. Then it's got to be 0, right? 0. Then we verify it. Alright, so let's write the coefficient of p of x. So 2, negative 3, negative 4, and negative 15. There's no missing term, so there's no zeros. Divide by x minus 3. So I'm going to use 3. Now let's find the remainder. If the remainder is 0, then x minus 3 is a factor. Alright, then bring it down. So multiply these two, then 6. Add it. Multiply will be 9. Then addition will be 5. Then multiply 5 by 3 is 15. Add it 0. So the remainder is 0, right? Remainder is 0. So x minus 3 is a factor, right? Factor of p of x. Because the remainder is 0. Since the remainder is 0, right? Since the remainder is 0. All right. Then what's the quotient? The quotient is the reduced polynomial. So this is the reduced polynomial. So 5 is the constant, x is the coefficient of x, and 2 is the coefficient of x squared. So this part is the quotient, right? Quotient, the reduced polynomial. So that p of x is equal to, okay, actually the p of x is 2x cubed minus 3x squared minus 4x minus 15. So once we factor this polynomial, and one of the factor is x minus 3, because when we divide the polynomial by x minus 3, the remainder is 0. And then the q of x. The q of x is the reduced polynomial, which is 2x squared plus 3x plus 5. That's it. So we can write the polynomial as a product of x minus 3 and this trinomial. All right, that's it. Okay, hope you do the exercise homework.